Imagine yourself on a vast, dark ocean. You are in a small boat, the Milky Way galaxy. All around you, as far as the eye can see, are other boats, countless other galaxies. You expect them to be drifting apart, pushed by the gentle, expanding current of space-time that began with the Big Bang. This is the universe we thought we knew, a universe where everything is slowly, majestically moving away from everything else. But something is not quite right. Your boat, our galactic home, is not just drifting. It is being pulled. Something is tugging on us, and we are moving at a staggering speed toward a destination we cannot see. We are hurtling through the cosmos at over 2 million kilometers per hour. That is fast enough to travel from New York to Los Angeles in about 7 seconds. This isn't just the gentle expansion of the universe carrying us along for the ride. This is a directed, focused motion. Think of it like a river. The entire river is flowing downhill, but within that river, there is a powerful current, a cosmic rapids, pulling a specific region of the water, our local group of galaxies, in a very specific direction. We, along with our cosmic neighbors, are caught in this inexplicable flow, heading towards a mysterious, unseen point in the intergalactic void. This motion is not a subtle hint, it is a cosmic shout. For decades, astronomers mapped the universe, expecting to see a uniform expansion, like dots on an inflating balloon all moving away from each other gracefully. Instead, they found this perplexing, large-scale deviation. It was as if someone had placed a massive, invisible drain in the cosmic ocean, and we are caught in its whirlpool. This realization sent a shiver through the astronomical community. The elegant, predictable model of our universe suddenly had a giant, unanswered question mark scribbled right across it. What could possibly be powerful enough to exert such a gravitational pull on a scale this immense? The journey we are on is not a solitary one. Our entire local group of galaxies, including the Great Andromeda Galaxy, is part of this cosmic caravan. And beyond us, the Virgo supercluster, and even the massive Laniakea supercluster, a colossal structure containing 100,000 galaxies, are all being drawn in the same direction. It is a cosmic pilgrimage of epic proportions, with trillions of stars and countless worlds all moving in unison toward an unknown gravitational behemoth. We are all passengers on this journey, and the destination is a great mystery hidden in the cosmic dark. The name astronomers gave this mystery, the Great Attractor. So, what exactly is this Great Attractor? In the simplest terms, it is a gravitational anomaly, marbles on a stretched-out rubber sheet. The sheet represents space-time. A small marble, like our sun, creates a small dimple. A bigger marble, like a galaxy, creates a bigger dimple. Someone places a bowling ball under the sheet. You cannot see the bowling ball, but you see all the marbles rolling toward the depression. The Great Attractor is that cosmic bowling ball, not just pulling on our Milky Way, pulling on a vast region hundreds of millions of light-years across, overriding the universe's expansion in our local patch. The Hubble-Lemaitre law. Galaxies should be moving away. For the most part, they are. But look closely, a strange additional, a peculiar velocity on top of expansion. We can add up visible matter in that direction. Stars, gas dust, and the numbers don't add up, like feeling a powerful gust with no trees bending, no leaves rustling. An enormous effect, the cause remains maddeningly elusive to our most powerful telescopes, a fundamental gap in our map of the cosmos, where our gravity theories and our census of matter seem to break down. Is there a concentration of matter so vast it defies expectations? A new type of cosmic structure? A wrinkle in space-time itself? Not just a curiosity? A clue, pointing to a deeper understanding of cosmic structure and forces. The Great Attractor is a cosmic whisper, telling us that the universe is far stranger and more complex than we ever imagined. The discovery of the Great Attractor was not a single eureka moment. It was a slow, meticulous process, connecting the dots, connecting the movements of thousands of galaxies. In the 1970s, in the 1980s, a team nicknamed the Seven Samurai embarked on an ambitious project. They set out to create a three-dimensional map of galaxy motion, not just where galaxies were, but how fast they were moving, and in what direction. A monumental task, like mapping ocean currents by tracking individual fish. They used a clever technique based on redshift, like a siren changing pitch as it moves. The color of light from a galaxy shifts. Light from a galaxy moving away is stretched to longer, redder wavelengths, redshift. But astronomers found something peculiar. In one direction, redshifts were smaller than expected from Hubble expansion. It was as if something was pulling them back toward us. Or more accurately, pulling both us and them the same way, reducing apparent recession speed. This was the cosmic breadcrumb trail. By meticulously measuring peculiar velocities, deviations from smooth expansion, the astronomers painted a picture of a massive, unseen concentration of mass. Every galaxy measured acted like a tiny weather vane. They all pointed in the same general direction, toward the constellation Centaurus, toward Hydra. They had found the center of the gravitational anomaly, the location of the Great Attractor. The data was undeniable, a vast stream of galaxies, a cosmic river, flowing across hundreds of millions of light-years. Our Milky Way, the Andromeda Galaxy. Both are the largest members of a small city of galaxies called the Local Group. That group, with nearby clusters, is being pulled toward the Virgo cluster. But the story does not end there. The entire Virgo cluster, our local group, thousands of other galaxies, all drag toward an even greater gravitational source. That source is the Great Attractor, a stunning discovery that redrew our map of the local universe. So if this Great Attractor is so massive and influential, why can't we just point our telescopes at it and see what is there? The answer is frustratingly simple. It is hiding in plain sight behind the one place in the sky we cannot easily look. It lies directly behind the plane of our own Milky Way galaxy. This region of the sky is known to astronomers as the zone of avoidance. We are forced to avoid it because our view is blocked. Stars, gas dust. Imagine standing in a bustling city square trying to see a landmark on the other side, throngs of people, buildings, bright lights, haze. The zone of avoidance is our cosmic city square. Looking through the Milky Way, light is scattered and absorbed, billions of stars, immense clouds of interstellar dust, like trying to look through a cosmic fog. The galactic plane wraps around our entire sky, creating a blind spot. This blind spot has frustrated astronomers for over a century. A celestial curtain hides a big chunk of the universe. The Great Attractor sits right in the middle of that curtain. A cosmic coincidence of the worst kind. The thing we most want to study is hidden by our own galactic glare and clutter, like solving a mystery whose clue is locked inside our house. For decades, the Great Attractor was a purely gravitational entity. A ghost in the machine, feel its pull map. Its influence could not see its face. Astronomers speculated what could lurk behind the veil, a single super-gargantuan cluster of galaxies, something far more exotic. The zone of avoidance turned a puzzle into a profound mystery, forcing new ways to peer through the cosmic smog. How do you look through a wall? Well, you don't. You find a different way to sense what is on the other side. For astronomers trying to solve the Great Attractor mystery, this meant turning to wavelengths of light that are not so easily blocked by the gas and dust of the Milky Way. While visible light gets scattered and absorbed infrared radio waves, it's kind of the same principle that allows your car radio to work inside a garage, even when your view outside is blocked. These longer wavelengths became our new eyes on the universe. Using powerful radio telescopes' infrared surveys, astronomers began a patient, painstaking effort to map the region behind the zone of avoidance. It was a bit like using sonar to map the ocean floor. Instead of light, they used radio waves emitted by hydrogen gas, which is a key component of galaxies. Slowly, painstakingly, a picture began to emerge from the static. They started to see them, galaxies, hundreds of them, and then thousands. An entire hidden population of galaxies was revealed, lurking right where the gravitational models predicted the Great Attractor should be. One of the most significant breakthroughs came with the discovery of the Norma cluster, a massive cluster of galaxies located right at the heart of the Great Attractor region. This cluster, designated Able 3627, is immense and packed with old massive galaxies. It contains a mass equivalent to thousands of Milky Way galaxies. Finally, here was a concrete, visible object that could account for a significant portion of the gravitational pull we feel. The ghost was starting to take shape. We were finally peeking behind the celestial curtain and finding the wizards responsible for the pull. But here's the twist. While the Norma cluster is huge, it's still not enough. When astronomers calculated the mass of the Norma cluster and the other galaxies they found in the zone of avoidance, it still fell short. The total visible mass they could account for was only a fraction of what is needed to explain the immense gravitational pull of the Great Attractor. The bowling ball under the rubber sheet was even heavier than we thought. The discovery of the Norma cluster was a giant leap forward, but it did not solve the mystery. It actually deepened it. It told us that the visible matter is only part of the story. So, if all the galaxies we can now see in the Norma cluster and surrounding areas are not enough to explain the pull, what is the Great Attractor? The leading theory, it's just the tip of the cosmic iceberg. The Great Attractor is likely not a single thing, but a vast, sprawling supercluster of galaxies, embedded in a larger, invisible halo of dark matter. This immense structure is called the Laniakea supercluster. It's one of the largest known structures, and we are inside it. The Great Attractor is the gravitational center of this colossal cosmic web. Think of Laniakea, immeasurable heaven, as a continent of galaxies. Our Milky Way sits in a small suburban neighborhood on its outskirts. The Great Attractor is the dense metropolitan core. Galactic rivers and streams flow downhill into this basin. The galaxies we see, even the Norma cluster, are the bright city lights. The true mass is the unseen infrastructure, dark matter. Dark matter, the mysterious, invisible substance, makes up about 85% of the universe's matter. We can't see or touch it, but we feel its gravity on stars and galaxies. NASA missions mapped the faint afterglow of the Big Bang and confirmed its abundance. Wilkinson Microwave Anisotropy Probe, Planck Satellite. The Great Attractor might be one of the best pieces of evidence for dark matter's large-scale effects. A huge pool of invisible mass forming a massive gravitational well. But some exotic ideas remain. Could it be something else entirely? Cosmic strings? Domain walls? Wrinkles in space-time? These ideas are speculative, but the Great Attractor is a testing ground for gravity and cosmology. For now, a vast, dark matter-dominated supercluster is the most likely picture, a cosmic giant still shrouded in mystery. The story of the Great Attractor is really the story of dark matter. It is a tale of the unseen universe flexing its muscles. The visible matter in the Great Attractor region is insufficient to explain its pull. That insufficiency is not a failure of observation. It's proof of a deeper truth. What we see is not all there is. The universe is dominated by substances that do not shine and that do not interact with light. The Great Attractor is a gravitational landmark, a beacon made by an enormous concentration of invisible material. Imagine walking through a forest at night. You can see the fireflies, you cannot see the massive trees. You cannot see the rolling hills. You cannot see the deep valleys. You only know they're there by how the fireflies move. The fireflies cluster in some areas and avoid others. In this analogy, galaxies are the fireflies. Dark matter is the invisible landscape dictating their motion. The Great Attractor is a deep, massive valley in that landscape. Galaxies in our vicinity are like fireflies sliding down its slopes. It's a humbling reminder our senses are tuned to only a sliver of reality. Scientists use every tool to map this invisible terrain. They study how light from distant galaxies is bent by gravity, gravitational lensing. From that bending, they create maps of dark matter concentrations. Those maps show massive clumps and long filaments connecting galaxy clusters. Together, they form a vast cosmic web. The Great Attractor appears as a major node, a massive intersection in that web. Multiple filaments have converged there, creating a gravitational superhighway that funnels galaxies inward. This invisible pull raises profound questions. How did so much dark matter gather in one place? Does dark matter behave in ways we don't yet understand? The Great Attractor is both destination and laboratory. By studying galaxies flowing into it, we can probe the properties of dark matter. Is it one particle or many? Does it interact with itself? The precise flow into the Great Attractor holds clues. It's a grand cosmic experiment by nature, challenging us to understand the 85% of the universe that remains stubbornly invisible. So we are being pulled. Our galaxy 400 billion stars, all of us on this little blue planet, is on a one-way trip toward the Great Attractor. What does this mean for our future? Are we headed for a spectacular cosmic collision? The short answer is, probably not, certainly not anytime soon. The distances involved are simply too vast. Timescales are mind-bogglingly long. Our sun will have long since burned out and died before we get anywhere close to the heart of the Great Attractor. So, there is no need to panic. The journey itself is the fascinating part. We are about 150 to 250 million light-years away from the Great Attractor. Even moving at over 2 million kilometers per hour, the journey will take many billions of years. The entire history of life on Earth is only about 3.5 billion years old. The universe itself is 13.8 billion years old. Our trip is a slow-motion pilgrimage across a big fraction of cosmic time. As we get closer, what might happen? Our local group will be drawn into the denser Virgo supercluster, and the whole structure will fall into the Great Attractor's gravitational well. Distant neighbor galaxies will become closer. Far future night skies might be filled with bright smudges of nearby galaxies. Eventually, galaxies may begin to merge stars and gas mingle in cosmic fireworks, forming larger, more massive elliptical galaxies. But this vision meets a more powerful force, dark energy. It drives the universe's accelerated expansion, a repulsive force like anti-gravity pushing everything apart. Right now in Laniakea, gravity is winning. The Great Attractor holds our supercluster together. Still, dark energy might ultimately win. It could tear everything apart, isolate superclusters, even rip galaxies apart. Our destiny is a tug-of-war, the pull of gravity versus the push of dark energy. The Great Attractor is more than just a cosmic mystery. It is an invitation. It is the universe beckoning to us, reminding us that there will always be vast, unexplored frontiers. It embodies the spirit of scientific inquiry, the thrill of the unknown, the joy of the puzzle, the humility of our small place in a grand cosmos. Every unanswered question is a doorway to a deeper understanding of the laws that govern everything. The universe is not a static, finished painting. It is a dynamic, evolving masterpiece. When you look up at the night sky, you are not just seeing distant lights. You are looking at your neighborhood. You are seeing visible parts of a colossal, interconnected structure, bound together by invisible forces, all engaged in a slow, majestic dance. You are part of a cosmic flow, a galactic river carrying you toward a mysterious destination. This realization changes your perspective. It connects you to the largest scale structures and the deepest mysteries. You are not just on Earth. You are a passenger in the Laniakea supercluster, on a journey toward the Great Attractor. The quest to understand this will push the boundaries of technology and imagination. Future telescopes like James Webb's successors, new radio observatories will peer deeper into the zone of avoidance. New surveys will map millions more galaxies with greater precision, refining our picture of the cosmic flow and the invisible matter that guides it. We are the first cartographers of a new world, sketching continents and oceans of our cosmic home, with the Great Attractor marked, "Here be dragons." In the end, the story of the Great Attractor is our story. It is the story of a curious species on a small planet, looking into the vast darkness and trying to make sense of it. It is a story of discovery, mystery, awe. It reminds us the universe need not make sense to us, but pursuing that sense, asking questions and following evidence, is one of the noblest things we can do. The Great Attractor pulls on our galaxy, but it also pulls on our curiosity, inviting us to look deeper, think bigger, never stop exploring.